going to introduce you to ratio to fractions worded problems. You have these in your maths class a lot. Ratio, fraction, written questions are high on exam papers, so you really need to understand them. So I'm going to start with a really simple question. In a class, the ratio of girls to boys is 7 and 11, 7 to 11. So remember, it's how it's written. So that'll be a girl to boys, and that's the boy. So write the fraction of the class that are girls and the fraction that are boys. So it's key to underline the bits that you need to understand. So you've got to find the fraction of the girls and the fraction of the boys. Now to do that, we need to know how many there are in total. So as we do in any other question, we're going to find out how many parts there are, but in this case, it's children. So we add our 7 and 11, which gives us 18. So we now know there's 18 children in total. It's asking for a fraction, so it's not difficult. So for girls, the answer is going to be 7 over 18. And for boys, it's going to be 11 over 18. And that's your answer. You've answered girls and you've answered boys. It really is as simple as that. It's a really easy question, that is. The next one, the ratio of red, blue to green counters is 4, 7, 9. A, write the fraction of the angle. Oh, sorry, I'm reading the wrong question. Write the fraction that are green. So we've got to find out our green counters. So I'm just going to do my little. We have red, we have blue, we have green. And it's written in order. So that's going to be 4, 7 to 9. So let's do what we normally do. We're going to add them all up. 4 plus 7 plus 9 gives us 20. It's 20 parts. So it's only asking us for the green, which is 9. So the answer is 9 over 20. Because it's asking us to write it as a fraction. So green is 9 over 20. Well, that's fairly easy as well, isn't it? Well, this one's a little bit more wordy. The interior angles of a quadrilateral are in the ratio 2, 3, 4, 5. Write the fraction of the angle sum for the smallest angle and then work out the size of that angle. Now, you probably think, oh my goodness, that doesn't make any sense whatsoever. So we're going to do it in steps. So we're going to add all these together. And when we've added all those together, it comes to 14 parts. Comes to 40, let's say 14 parts. Write the fraction of the angle sum for the smallest angle. So let's look for the smallest angle. 2 is our smallest angle. So it's going to be 2 over 14. And we can simplify that. 2 goes into 2 once, 2 goes into 14 7 times. So the answer for A equals 1, 7. So let's work on B. Work out the size of that angle. Now, here, we know that a quadrilateral is 360 degrees. It's really important. So to work out the size of this angle, what we're going to have to do is 1 over 7, which is our angle, and we're going to times it by 360, which gives us 51.43 degrees. Now, I've used my calculator here, my scientific calculator that I swear by. It's perfect for these kind of questions. So, the first step is to find the smallest angle. We've done that. And then it's work out the size angle. So the key piece in a quadrilateral and angles in a quadrilateral, the angles in a quadrilateral is 360. So maybe you could have written that first. So, you know, you had that piece of information when you read the question. So that is a little bit more trickier and there's a bit more worded to it. But if you break it down like I have, you should be able to solve it with practice. Not saying you're going to understand it straight away, but with practice you will. In a school, the ratio of students studying French, Spanish and German is 6:5:4. Write the fraction of students studying Spanish. So we've got French, which is 6. We have Spanish, which is 5. And we have German at 4. So do our usual, add and find out our parts in total. Which gives us 15. So the question is, write the fraction students studying Spanish. Well, we know there's 5. So it's going to be 5 over 15. Now we could leave it like that, but we won't because we simplify, don't we, our fractions. So 5 into 5 goes once and 5 into 15 goes 3. So the answer to that question is 1 over 3. And then your old classic, the ratio of blue to red marbles is 5:7. What fraction are red? And if there are 84 red marbles, how many blue marbles are there? So let's sort out this bit first. So we have 5 plus 7. So those are 12 parts. What fraction are red? Well, we know that this is blue and this is red. So we now know the fraction of red is simply 7 over 12. That was easy. So let's look at the next one. Let's look at B. If there are 84 red marbles, how many blue marbles are there? So to solve this, you have to look at 7 parts of red. We know that there's 7 parts red. So we're going to do red, 7 parts equals 84. Because 7 times 12 is 84. And then we have 5 in the blue. So we're going to do 5 times 12 equals 60 blue marbles. So there we go. That's solved really. So we have, if there are 84 red marbles, so we've worked out what our red marbles are, 7. What we did was we times 12, which gave, I'm going to put that there actually. We did 7 times 12 to get to 84. So we sorted out this part of the question. How many blue marbles are there? 5 times 12 equals 60 blue marbles. So there we have it. Some introduction questions with worded ratio to fractions. This is part 1, so there will be a part 2, but that will be a little bit more in depth. It will be more like these kind of questions where you really have to think about it. But for foundation, I would say this kind of question, that kind of question, and possibly those two towards the back maybe. Okay, so I hope this helps. Speak soon for part 2.